I'm building an AI system that runs entirely on my own computer. This isn't just another chatbot. I want something that can analyze folders, do research, and eventually be trained on my own data so it can work fully offline. To get there, I'm going to start with a large teacher model and then teach everything it knows to a smaller model that lives on my machine. Main goal, here's the core idea. The teacher extracts, the student learns. I'll use a powerful teacher model, GPT-OSS 120B, to generate high-quality data. Then I'll train a small local model on that data. The end result is something fast, private, and built specifically around how I work. 03. Why 2 models? The problem is simple. 120 billion parameters does not fit on an 8GB GPU. Running a model that size locally all the time just isn't realistic on consumer hardware. So I'm splitting the work in two. The big model teaches, the small model runs. What I did today was about locking in the concept. I chose GPT-OSS 120B as my teacher model. I set a clear target for the student model. It has to fit inside 8GB of VRAM, and I mapped out the overall system logic that ties the two together. System logic. Here's how the pipeline works, step by step. First, a teacher agent reads through my files and folders, analyzes them, and writes reports. Second, every solid piece of that analysis gets converted into training data. Third, the student model trains on that dataset, learning the teacher's analysis pattern. And finally, the result is a local AI system that runs on my own machine. Fast, offline, and personalized. Local goal, the end goal, is a system that runs entirely on my own machine. Something fast, something that can actually analyze my folders, and something trained specifically around how I work. Not just a model that answers questions, but one that gets real work done. Why it matters. Instead of renting an off-the-shelf AI, I'm building my own system from the ground up. That gives me full control over what it does. It runs offline, my data stays private, and I can keep improving it over time. Next step. So what's next? I need to pick a student model that realistically fits an 8GB GPU. I need to design the data structure the training set will follow, and then I can start generating the actual dataset from the teacher models. So that's where things stand. The teacher side of this project is locked in. In the next episode, I'll pick the student model I'm actually going to train locally. The goal is simple, a small model that's still powerful because it learned everything from a much bigger one.